Have you ever stopped to think about something really simple? Something you see all the time? Go get a glass of water. Now drop an ice cube into it. What happens? It floats. But why does frozen water float on top of liquid water? Most things, when they turn into a solid, sink. But water is special. It breaks the rules. That rule breaking is incredibly important for life on Earth. So let's dive into the science behind it. Imagine you are holding that cold, slippery ice cube. The ice feels solid. The water flows freely. They are both the same thing, H2O. Place the solid in the liquid, and it bobs to the top. It doesn't drop like a rock. That's a big clue. Look closely and ask why. Science starts right in your glass. To understand why ice floats, we need to shrink down, way, way down. Smaller than a grain of sand, smaller than a speck of dust. We need the world of molecules. Everything around you is made of molecules. Your chair, the air, the water in your glass. Think of molecules like super tiny Lego bricks. In liquid water, molecules move like dancers in a crowded room. They slide, bump, and always, always move. That motion lets water flow and take the shape of its container. They hold hands, let go, and grab new partners as they move. Now, think about the ice cube. When water gets cold, the molecules lose energy and slow down. They stop roaming and start locking into place. Liquid is messy. Solid ice is a neat, repeating pattern. We know ice is more organized than liquid water. But how does that make ice float? We need an idea called density. It sounds big, but it's simple. 2 suitcases, same size. Books make one heavier. That one is more dense. More stuff packed into the same space means higher density. Less stuff in the same space means lower density. Things float if they are less dense than the liquid. A log floats. A rock sinks. For our ice to float, it must be less dense than water. Same space, less water stuff in ice than in liquid. Most solids pack tighter and sink. Water breaks the rule when it freezes and opens up. The crystal isn't packed tight. The beautiful shape of ice is the reason it floats. It all comes down to shape and connection. One big oxygen, 2 smaller hydrogens on one side. One side is slightly positive. The other side is slightly negative. Opposites attract, forming hydrogen bonds. In liquid water, bonds form, break, and reform. Molecules pull close and fill tiny gaps. It's chaotic but packed in. When water freezes, motion slows. Bonds have time to line up properly. They build a 6-sided hexagonal lattice. Each molecule holds a set distance from its neighbors. That strong structure has open channels and empty gaps. Compared to liquid, ice takes up more space. Same number of molecules, more volume when frozen. Less dense than water. That's why ice floats. We solved the mystery, but what if ice sank instead? On a freezing day, surface ice would form, then sink, layer after layer, filling the lake with ice. Fish, plants, and tiny creatures would freeze. Life in lakes could not survive winter. In our world, floating ice makes a protective lid. It insulates the water so life can survive. Floating ice also reflects sunlight, cooling Earth. If it sank, oceans would absorb more heat. Ice affects ocean currents and weather patterns, helping keep our climate more stable. So, when you watch an ice cube bob up, remember the science at play. Simple things can hold amazing secrets. Science is everywhere, even in a simple glass of water. If you learned something new, hit like and subscribe.